Hi, today we're going to discuss food allergies and sensitivities and the link to biotoxin illness. And I just think it's important to realize that, what we see in this category of people with, Lyme and CIRS is that there's this chronic inflammatory surge that's taking place. It's not found in traditional labs. However, in general, what we're seeing is that, we're looking at this process of metaflammation or metabolic inflammation and understanding that there's a lot of ways that people end up in trouble with chronic metabolic inflammation. And with metaflammation, obviously the downstream issue with it over time is, the loss of neuroplasticity, mitochondrial damage, changes in insulin receptor function, changes in the way our body uses its energetics. And I think as you work with, CIRS cases and vector-borne cases, it's one of the key features of what happens with them. And so I'm not going to spend a lot of time. Obviously, you've got a whole weekend of learning about biotoxin illnesses, Lyme, and the gut. And I know you got a lot of speakers that are kind of going over all this. I'm going to do a really quick review of it, and then we'll kind of get into the value I think that food allergy and sensitivity testing has on really kind of supporting individuals so that you're downloading some of that chronic inflammatory signaling that may be going unnoticed, especially if all you're doing is doing traditional IgE and IgG testing. And without a doubt, there's a component to the process where as people get chronically inflamed and their brain is pumping out more interleukin 6, by default, interleukin 6 upregulates claudin 2. Claudin 2 then has an effect on the cytoskeleton structure known as the tight junctions between the epithelial cells, which can lead to kind of gapping and an erosion of tight junction integrity, which leads to issues like bacterial translocation and heightened immunologic drive. So obviously, the big pioneer in this spot, we got to give our props to Dr. Richie Shoemaker. Obviously, Dr. Heyman, who does a lot of work with Richie, works with me. I actually co-chair underneath him at A4M as an educational co-chair. He, of course, is the chair. And they've published a lot of research in this space and have looked at an awful lot of brain imaging as well. And so, it's this exposure piece to mold and other biotoxins, 80% of the cases due to repeated exposures or to chronic exposure to water damaged buildings and dwellings. And of course, we're now finding out it's more than just about the mold, that actually the bacteria actinomyces is playing a bigger and bigger role in the symptoms and the genetic expression or the omic side of what's going wrong with these individuals. World Health Organization estimating 30% of newer renovated buildings are sick buildings. And then, of course, with Lyme, that's become somewhat epidemic. And one of the biggest issues that we have there is getting accuracy of testing and really identifying that Lyme or Lyme-related disease. So I'm including the fact that I know you're learning about Bartonella and Ehrlichia and other organisms that are also kind of pulled through in that experience. But in the end, both of these situations lead to immune dysregulation and metaflammation, as well as leading to microbiome disruptions and a leaky or heightened permeable gut. And of course, that can also lead to more of an autoimmune behavior with the immune system as well. When you look at CIRS epidemiologically, we see 22% of the US population carry the HLA alleles. That's about 40 million people. And of course, as it's been so eloquently described, folks with those HLA gene SNPs are more prone to exhibiting these immune alterations that take place. And so really important to keep that in mind is that, yes, there's a genetic predisposition, but, there's people that get into problems with metaflammation that don't have that HLA gene SNP. It may not be CIRS, could be CIRS, but it's just important to note that this metaflammation bucket leads to what's called aging or inflammatory aging, meaning that our immune system is kind of wreaking havoc on our tissues and damaging our tissues. And of course, with tick-borne diseases, I just want to drop to the bottom because I know you guys are getting all this information. There's 300,000 Lyme cases, and that in 2013. And that also indicated there could be up to 1 million cases in the US at that time. And it doesn't include undiagnosed or misdiagnosed cases. So I know this is still an evolving science as we're working through the omic side of how people are truly getting affected by these conditions, but we're getting closer and closer to them. And as evidenced by, for example, the omics testing as it relates to CIRS and looking at what genes have been activated and turned on that are causing problems or wreaking havoc for individuals. Now, with chronic mold exposure and allergies, just keep in mind that we do upregulate IgG and IgE. This was kind of, multiple studies showing that environmental mold and mycotoxin exposure elicits specific cytokine and chemokine responses. And so you're turning up that inflammatory signaling. The reason I'm emphasizing that is, in the end, what we're trying to do is if you can envision that person as having this bucket or trough of inflammatory downstream metabolites, what we're really trying to do is get as many of those things out of there as we can. And so if we can identify what's going on with that individual in terms of, for example, secondary issues like food allergies, which can upregulate the complement pathway, C3BD, can upregulate IgG4, which is linked to evolving autoimmunity. Well, then that's going to do nothing but help us with our total burden, right? So when you look at this, meta-analysis here shows building dampness and mold associated with approximately 30 to 50% increase in respiratory and asthma-related health outcomes. We know that. That's why we're all here, right? And then mold exposures report an increased sensitivity to other commonly inhaled microorganisms and inert substances. Yeah, right, because we're upregulating histamine genes. It's not just the fact that we're getting this mast cell activation that takes place. It's the fact that the new science is saying that you're turning on these histamine genes on all your cells and you're creating all this histaminic response. And that's what's so challenging, right? Is because we're trying to get all that histamine under control. And once again, we're going to go through histamine later in our talk. And we've only got an hour, so I'm going to keep rolling. And so, when you look at mold exposure on IgG and IgE, this was on mold-derived antigens in 70 mold-exposed individuals versus 31 controls. And basically what this showed that, under normal limits of the controls, IgG titers were still there. But what they found was that in mold-exposed individuals, their IgG titers got upregulated and stayed kind of consistent. So they stayed upregulated on their IgG response. True, this was only looking at the mold experience, but we know that when you upregulate that inflammatory response and the gut is now activated or now permeable, that it creates that opportunity for creating more allergic or sensitive reactions to food. And that goes beyond just the kind of traditional list you get for, don't eat moldy food, right? Which I'll show you the list, but it's getting that understanding that it could be any food that's creating these really deep seated immunologic drives that are causing even more inflammatory cascades to occur. Above and beyond that HLA, activation and all the inflammatory, measurements that you do when it relates to a CIRS case, whether you're looking at MMP9 or TGF beta 1 or IL-1 beta, anti-cardiolipin antibodies, C3A, C4A, whatever that's happening due to the exposure and that gene activation. You got this other side of the coin that is due to the gut getting compromised, because once you trigger neuroinflammation, the enteric nervous system is going to have a lot of pressure on it from sympathetic dominance that'll go through those enterochromaffin cells and activate that permeability in the gut, which will then trigger more antigen and inflammatory response. I know I've got some slides on that, but I just want to kind of heighten that situation. So, when we go through this, obviously with food allergy testing, there's common issues with Lyme patients and CIRS patients related to food sensitivity and tolerance. Many times they report intolerances to food. They get put on restrictive diets over a period of time. And, our end goal should be is to try to get people back to as many foods as they can tolerate, right? We've all been in this a long time. I mean, I've been in this for 37 years, and I realized that I've got to get people to have as broad of a food selection as they can so they can live a normal life. That being said, many times the major food allergies like cow's dairy or gluten may be out for an individual forever if they've got celiac or type 1 diabetic with HLA genes, whatever the reason is. There may be specific limitations, but what we really want to try to do is get people to understanding, what's my macro balance, what's quality food choices, what are foods that aren't going to trigger inflammation. I just talked to a trainer yesterday who, went from, being in the 90s with their blood sugar and being insulin resistant, and she's petite, to doing a food allergy test on her, and her inflammatory markers went down in her body, and she dropped some body weight. And more importantly, she started thinking more clearly, and it was very evident to her. And so that tells us that, at the very least, food allergies and sensitivity testing and getting rid of those foods may help clear some of that brain fog, right, in individuals. So Lyme leads to mast cell activation, of course, CIRS as well. Rampant histamine gene expression is the thing I think that is the interesting findings that I know Dr. Shoemaker has been on the forefront of looking at. And then, of course, this increased expression of all those likely characters, TNF alpha, IL-6, IL-13, TGF beta-1, MMP9, beta, and PAI-1, or plasminogen activator inhibitor 1, as well as C3A and C4A, and probably a host of other stuff, right? Look at homocysteine. Look at oxidized LDL, look at deoxyguanosine, right, for DNA damage. I mean, there's a whole battery of things you can look at. Even galectin-3, for that matter, could be an interesting inflammatory marker. So keeping in mind that, we're of course casting that net as wide as we can to characterize inflammation signaling. And I think that food allergy testing now is more becoming accepted because a lot of studies have been finally publishing on the relevance of IgG, the relevance of IgG4, and what's happening with individuals in those situations, and the proclivity to move towards a chronic disease or contributing to their chronic illness or inflammation. So, I think that 20 years ago, when IgG testing first came out, or it was ALCAT, or it was another type of test, we're all kind of scratching our head going, is this valid or not, right? Gee, I just do the test and their foods just come back with all the new foods they're eating. So is this just a transient marker of what's going on with them? But I think the evidence is really pointing in the other direction now. So we got to pay attention to it. So, obviously there's this, response that occurred that was, in 2019, there was the research report that ticks induce an immune response. Even for those without recently being exposed to mammal blood during feeding. And this is that whole alpha gal syndrome, which could be potentially life-threatening. So watching for that reaction to meat. And this was, of course, 2019 annual of the American Academy of Allergy, Asthma, and Immunology, 2021 access. So this is brand new and a pretty traditional journal, kind of recognizing the immune dysfunction that occurs in these, tick-borne illnesses. And once again, you've already went through these symptoms. I'm not going to go over them. I just put it up here so that, you've got it in one spot. But obviously, symptoms can be mild or severe based on AGS. So that reaction to meat can be everything from rashes to hives to nausea and vomiting to difficulty in breathing or drops in blood pressure, or dizziness or faintness, severe stomach pain. But once again, you may have to watch even gelatin-containing, foods. So very popular for people to drink collagen now to repair their gut. You may want to be careful with that in that instance if you know that they're in this situation. And of course, this was the classic slide, I think, that's very clearly showing that the normal person that doesn't have that aren't susceptible. The biotoxins get recognized, they get bound by the immune system, and they're removed through the stool if you're non-susceptible. However, in this susceptible individual, person's exposed to a biotoxin, biotoxins aren't recognized properly by the immune system and aren't removed, and they can remain in the body indefinitely. So one of the reasons, why do we give binders? We're giving binders to bind up inflammatory compounds and biotoxins. And those biotoxins can pass from cell to cell. That creates direct damage, but and damage to the immune system, but it also can cause immune system dysfunction. So we start to misfire basically what's going on. And once again, that's why I think identifying foods can be incredibly important because it's one facet of immune missignaling that is perpetuating the problem of inflammatory processes, and therefore can be invaluable in terms of a secondary test that I think people should really get towards earlier in treatment versus later in treatment. Because you know what? You're going to do your protocol for biotoxins anyway, right? So you're going to do your protocol. But in that process, you could also be giving people a very specific food list that would help them reduce their inflammatory signaling that's occurring due to the food they're eating and the immunologic drive that's occurring in the gut. And so, of course, the inflammation causes multiple symptoms across the body and many times leads to misdiagnosis. And of course, patients end up being, suffering unnecessarily. And of course, that's why we're here. That's what you're learning about this weekend. And of course, the symptom clusters on biotoxins are significant. So everything from weakness and fatigue to headaches to electrical discomfort or clawing discomfort, unusual sharp pains or electrical feeling, redness, light sensitivity, shortness of breath, obviously allergic symptoms, abdominal pains, a lot of irritable bowel, right? And remember, the irritable bowel can be due to all those biotoxins and the inflammatory chemistry that's going on. But the bottom line is when that inflammatory chemistry is going on in the gut, you are more than likely breaking down that gut and having hyperpermeability. And of course, other things like that foggy brain and cognitive issues due to glial cell activation. And of course, remember, when the gut gets permeable, the blood-brain barrier gets permeable, and that leads to secondary problems like metals and other kind of things that can stack up, right? They can add on to the already significant problem that's going on. And of course, it can, create changes in mood. Obviously, we see people with problems with insomnia, with anxiety, with depression. They have appetite issues. They have thermoregulation issues. They gain weight. They get numbness, tingling. They can get vertigo, tremors. All sorts of things can occur, obviously. And these are some of the common misdiagnoses that occur. I know that's why you're here. You're here to learn about how you can help individuals that have these seemingly kind of resistant to treatment processes. There's plenty of people that, you give them some theanine, you give them some Relora, you give them some holy basil, and their anxiety gets managed, right? But then you've got folks that, you throw the kitchen sink at them on everything that you were trying to do and nothing's working. And you really want to try to identify, well, where that problem is at. Obviously, what we see is a lot is in our context with, looking at algorithms is that, gut immune brain is always like the big area that people are dysfunctional in. And of course, that's followed by their detoxification processes and inadequate detoxification in the liver, gallbladder. And then secondarily looking at GFR, because remember on the kidneys, a huge amount of mast cells are in the kidneys and are really prone to oxidative damage due to that oxidative burst that can occur because kidney tissues are really, to keep them adequate, really have to be balanced with redox poise, meaning my oxidation reduction reactions are intact. And I think we find that that's an issue. And you may see that in some of your subpopulations of folks with, vector-borne illnesses or with biotoxins. Obviously, there's these foods to avoid. You guys know this standard list. I just put them in here because you can at least have it in a slide. But what I'm saying is don't just believe this list, which is obvious because it's moldy and people may, trigger due to it. But it's really about identifying all foods that are triggering an immunologic response, not just histaminic, but the complement immune pathway as well as with IgG4 upregulating the autoimmune activity that can take place in individuals. And once again, more, common inflammatory foods to watch out for. But once again, I'm going to say that at the bottom, and, in the heightened statement, however, gut permeability changes in any food can become reactive. It could be the healthiest food in the world. It could be cauliflower, right? And you're not going to be able to have it because you've upregulated your immune complement pathway for cauliflower, for example. So what's the importance for this food allergy testing? I just kind of want to make sure that we revisit the statements of it. Food allergy testing is directly related to gut immune brain issues. When the enteric nervous system is triggered in either direction, meaning I have neuroinflammation, microglial activation, Due to biotoxins, that means that by default, I'm going to trigger sympathetic dominance response that's going to travel across that nervous system and lead to gut permeability problems. And some of the symptoms that relate to biotoxin illness, could be cross-correlated to what's going on with this food allergy response. Now, I'm not saying you're going to get rid of, all of the, obviously the biotoxin issues. You've got several stages, right, that you go through in order to correct a biotoxin exposed person that can take up to several months. All I'm really hoping to get across to you in this hour is that identifying food reactivity reduces the inflammatory burden. Get that trough of inflammatory chemicals to lower so that potentially you can at least get rid of some symptoms or lighten some of the symptoms of that individual. And that's going to basically decrease that inflammatory compound production and support the management of that biotoxin illness individual. So looking at, food allergy testing, so allergy versus sensitivity, I just want to review this quickly. Obviously, with IgE, there's an antibody response that leads to an allergic reaction to foods. It can occur immediately, so you can have anaphylaxis, right, within moments. Typically 1 to 3 hours after ingesting a food or liquid, people will have atopic dermatitis, allergies, eczema, psoriasis, the obvious asthma, sneezing, runny nose, itching, headaches, nasal congestion, wheezing, shortness of breath, scratchy, continued clearing of throat. I would also add in here, because of the histamine response, insomnia and anxiety. I don't think we appreciate enough the issue around histaminergic drive and how it affects the brain. Or why else would we take an antihistamine for bedtime, right? You walk into every pharmacy, what is it? It's full for sleep. It's full of products that are just basically antihistamines. And that would be your clue, right? If I take an antihistamine driven sleep aid and it puts me out, that means I'm probably histaminergic. Now, on the IgG side, of course, these foods are sensitivities that occur over delayed reaction, typically between 3 and 72 hours or more. And, they usually can improve easier than IgE, right? You can work to clear IgG responses a little bit quicker. But it does lead to low-grade chronic inflammation if they're being triggered consistently. And it can also have a secondary effect on driving histaminergic response. The IgG4 test, it's a complement to IgE antibody response. It's basically blocking IgE. So it's limiting how much IgE is actually going to hit the receptors and drive those mast cells. So high levels of IgG4 will lead to an inflammatory response. It contributes to eosinophilic esophagitis, contributes to disturbances in thyroid, ovarian, and prostate tissues. And so it's something you really want to pay attention to. And recent literature would say that IgG4 is absolutely correlated to increasing autoimmune risk. I've written several white papers regarding this, and you certainly can get those white papers if needed. The C3BD complement, once again, it's the complement to IgG. So IgG4, the complement to IgE. C3BD is the complement to IgG. If there's any C3BD present, then the body's response to that food will be amplified dramatically, estimated to be about a 10,000-fold increase in activity in the reaction to the food. And of course, if there's any IgG present with that C3BD, you get a significant increase in symptoms. Why we like C3BD is it's just a wider net of testing for the complement. So there's companies that have C3B. I like C3BD just because I'm getting a more refined test, and I think why not, right? So when you look at sensitivities versus allergies, just to be clear, sensitivities can occur at any age. I was just on a phone with or a Zoom call yesterday with somebody who, history of anorexia, had a Whipple, had pancreatitis. And she said, well, I used to tolerate foods just fine. Well, yeah, well, you weren't traumatized like you are now, right? So it's the fact that they can occur at any age. It's approaching 50% of the population may have a sensitivity. They're typically they're not life-threatening, but typical things like bloating and joint pain and irritable bowel and being fatigued, feeling foggy-headed, maybe eczema. Changes in mood, definitely. There's some literature out showing that people with depression, people with different types of mood disorders can have heightened IgG response, for example, weight gain. So all of those things, right? And then it can be self-assessed, right? You can look at your pulse if you want to. You can do blood testing if you want to. Which I'm obviously a proponent of doing an accurate blood test. And the reactions are occasional, as I said, 3 to 72 hours. And then common causes, wheat, dairy, corn, eggs, sugar, sesame, soy, and then of course environmental triggers. And you could have multiple ones, right? When you do a test for this, you could have multiple different foods that are reactive. On IgG reactions that are the classical, or IgE reactions that are on the allergy side, that are the classical IgE, that's typically anaphylaxis. It's 2% of adults, 6 to 8% of children. They can be life-threatening. So you want to be awake, want to be ready to go. And if the throat's getting scratchy right away after eating something, that's, get after it and get help immediately. Obviously, if you've got some ascorbate C, you can start drinking it and while you're getting your EpiPen fired up, or if you're, calling 911. A very, since it's an immediate reaction, it's easier to identify, but of course, self-assessment, I'm not recommending you challenge yourself. It's easier to identify because it's pretty immediate, typically within 2 hours of exposure. And then the common causes that, obviously peanuts, tree nuts are added in, fish, shellfish, certain food additives, medications can be IgE, insect things can be IgE, right? So that's the variation or the difference. Why IgG4 is so important, because it's an indicator of allergen exposure. For one, it decreases your false positives. So if you got a moderate IgE and no IgG4, maybe you're not as concerned about that. Obviously, if you're in the red on IgE and you have IgG4, that means you're really loading an allergic response. So measuring IgG4 levels really allow you to either rule out or confirm an intolerance as a cause of symptoms. This was a 2015 study in World Allergy Organization journal. So like I said, the evidence is starting to come out over the last 5 years regarding these subclasses like IgG4 and complement pathways. And of course, for C3BD and the complement, it's, IgG causes generalized metabolic inflammation, which can trigger symptoms, and C3BD dramatically amplifies that response. So you get a dramatic upregulation of that metabolic inflammatory response, and it regulates the development of the Th2 side of immunity during allergy sensitization. And by measuring that complement that binds to IgG, you're going to be more likely to find those titers that have the most inflammatory potential. So for example, if you have C3BD tested and it's positive, you want to make sure people are avoiding those foods without a doubt. And then you would move over to, and you'll see in a report that I'm going to show you, that you'd move over to the red IgGs, I would still remove. But anytime a C3BD shows up, you want to definitely pay attention to that. And, and once again, remember, a lot of this complement pathway, like C3A, is getting upregulated in these individuals with biotoxin illness anyway. So now all you're doing is adding more fuel to the fire through these C3B and D complement paths. And even in this particular continuing education piece, which in the differential diagnosis of food intolerances, if you look under the immunologically mediated food allergy, you look at the drop down on type 2, there's an upregulation of C3A. So yes, biotoxin, inflammatory compounds that are a byproduct of that, the omics expression in the individual is driving C3A, but just the fact they're reactive to foods could be driving a portion of that C3A and giving you less than the desirable results that you're looking for. And of course, this is related to their delayed type allergens as well. So you would bucket this into not necessarily an anaphylaxis. So if you see the differential here, you've got type 1 IgE antibodies, which create that immediate allergy response. But then you may test and you have this immediate food allergic response that's being driven down your immune complement pathway. And I think it's really important to grasp this slide, which I recently just found, by the way, and was thought, wow, this really clearly depicts why it's important to think about food allergy testing, because of this type of C3A activity that takes place, driving a delayed type allergy response. So, what can cause food allergies and sensitivities? I know you're having a great talk on the gut and it's going really in depth at some point this weekend. So I'm not going to go in depth in regards to that. I'm more just concerned about, brushing across the issue, and then just getting into, what's the food allergy test look like, and how you can implement it within your practices. So obviously the why food allergies can develop. I mean, it can develop neonatally, right? So there's studies that show when women took probiotics in their third trimester, that their infants were 40% less likely to develop allergies and eczema, of course, which leads to asthma, and that you can get reduced circulating IgE antibodies just by giving probiotics. Now we know there's more to it than that, right? We got to think about prebiotics, and we got to think about the dysbiotic flora. Do we have to kill some bugs? Do we have to restore integrity of the epithelial cells, things that help generate mucin and provide glutamine to fatten up those epithelial cells? So of course there's that aspect of, is there toxicity? Do we have to do restoration? Is there an ongoing good prebiotic fiber, as well as the needed use of probiotics and what the individual needs? But as we have an association or development of food allergies or intolerances, we see specific, allergic response. You see more pro-inflammatory cytokines and reduced balance in the anti-inflammatory cytokines. And of course, it inhibits accumulation of T regulatory cells and suppresses the tolerogenic side of the immune system. So this is something that progresses in life. So, you're a 35-year-old, you get exposed to mold, you may already have all these food allergens that are going on, but now you're living in a toxic building, you moved, or you changed environments, you went from an arid climate to a humid climate, whatever the reason is, right? But most of the time, you probably agree that a lot of people are already in trouble with their gut, regardless. And of course, it's important because the gut's such a big surface area. You spread out the small intestine, and what do you get? The surface area of a tennis court. That's a lot of surface area, right? 70% of the immune system's in the gut. And of course, we need to make sure that we're attending to the integrity of the gut. And that mucosal lining of the intestines, it's really important because it's the protection to those endothelial cells. Those epithelial cells have one layer thick, right? And when you damage the tight junctions, that means that sieve becomes bigger. It's like that story of, if you think of a tennis net, and if I'm trying to throw a tennis ball through the net, it's not going to make it. If I try to throw a ping pong ball through the tennis net, not as many of them might make it, probably ain't still going to make it. If I throw a BB through, it's probably going to make it. And so the more either we create gaps in these tight junction integrities, the bigger particles can get through. We have non-digested foods because mainly people have poor digestive processes, and they are either peptides or proteins that then sift through and can create a reaction. But then it's the issue related to bacterial translocation, right? You get bacteria that don't belong because they're getting across the tight junctions now because they've been compromised. And of course, probiotics are important because they help with the upregulation of mucin, which is, in butyrate, which helps with the integrity of these one layer thick cells. And remember, as I'm triggering the inflammatory process, I start to erode these epithelial tissues, as well as the lamina propria, or the basement membrane. And so those epithelial linings being one layer thick, it's the only barrier between the intestine and the bloodstream, and they're joined by those tight junctions, and they're dictated by occludin and zonulin, right? Normal levels of lymphocytes in the epithelial cells maintain your tight junctions. So when they're a normal amount, it's great. As soon as you start to get excessive lymphocytes, you start to damage the tight junctions. And of course, there's gut-associated lymphoid tissue that act as a protective containment against those intestinal antigens reaching the bloodstream. And that induces tolerance, which is involved with secretory IgA, which we'll go over in just a little bit. And then it's composed of Peyerpatch cells, so the immune inductive cells, effector sites for the intraepithelial and lamina propria. So there's this whole defense system or network that's supposed to be there. The problem is it gets under attack relatively quickly, especially in a world where people have been treated with multiple rounds of antibiotics. They've been around glyphosate. They may have toxic metals. They multiple different drugs. Actually, I'll show you a slide that affects the gut. And so people are already positioned before the biotoxin or vector-borne illnesses are taking place. They're already kind of compromised, and typically they're in a pro-inflammatory stance already, even though that might be hidden. It's waiting to bloom. And, I kind of already went through that. So, it's pretty simple, and I'm going to move on from here. But if you look, pathogens and nutrients are floating around in the gut. And of course, that mucosal barrier is tight, and that tight keeps the bacteria out. And we normally absorb our nutrients for the most part, through those epithelial cells in a controlled way. But then we get antibiotics, we have autoimmunity, we have dysbiosis. I've been on a lot of antibiotics. I'm under a lot of stress. I'm growing candida, whatever. I've got a protozoa. I've got H. pylori, whatever it is, right? And then it could be infection. It could be low stomach acid. And look, low stomach acid, epidemic, guys, right? It's epidemic because, one of the top selling things out of every drugstore in the United States are people taking acid blocking medications. It's super common to take acid blocking medications because people aren't identifying their food allergens. So they get GERD and they get reflux and they get bloated and they get uncomfortable. And of course, toxins, which I mentioned, things like, pesticides, toxic metals. And what happens then is that we start to trigger an antibody response to foods. We get compromised junctions. We start to get immune complexes in the blood, as well as toxins being able to get through there, as well as bacterial translocation, right? So pathogens can then start to get in. And so pretty big reason for why we want to heal this gut up while we're trying to heal people. So big involvement, on the gut. Obviously, medications are one. Stress is huge because stress, you're going to upregulate IL-6. IL-6 is going to break that gut down. Diet, look, I'm not here to tell you there's any one diet that works for everyone. I think that's a little bit naive, but we do know that, in general, people do better eating more plants. And then macros are different. It depends on where you're at, where you're at with your insulin resistance. What do you tolerate genetically on your carbs, right? And then alcohol use, this last year and a half with the pandemic, think how many people were having virtual happy hours every day. And, we all talked to people where we saw that their alcohol intake is up, and, increased alcohol intake equals more damage to those epithelial tissues. And we already talked about environmental chemicals, lipopolysaccharide, obviously from the death of flora, which is, can be compromised by a lot of different ways. And then of course the dendritic cells. So any of these things can cause dysfunction. Just looking at lipopolysaccharide, for example, this is kind of the latest theory on obesity, that lipopolysaccharide crosses the blood-brain barrier, triggers microglial activation, which triggers brain inflammation, gliosis, and inflammatory cytokines, which then throw off all of our hormonal signaling, in particular insulin receptors, which are very vulnerable to inflammatory signaling. And so we gain weight, right? So, that's why I repeatedly say, find out what foods are creating that inflammatory response, get them out of your diet. Don't just guess. Don't just give people a list. Test them, find out where it's at. And this, of course, is a reiteration of the issue around stress, and that stress can be a vector, it can be a metal, it can be a biotoxin, it can be nutrient deficiencies, deficiencies in choline, whatever, right? It can be just any kind of stress that hits the HPA axis. Two pathways that really take place here. One is the upregulation of the HPA axis, increasing cortisol. And if you look to the center of this graph, you'll see that there's an upregulation of permeability in the gut. And then the second one, of course, is that HPA axis triggering the spinal cord to trigger upregulated sympathetic output, more adrenaline, more noradrenaline, more excitotoxicity, which activates the enteric nervous system via the enterochromaffin nerve fibers, which triggers an increase in peripheral corticotropin releasing hormone, which one causes a permeability change in the gut, and secondly, increases mast cell activation. And remember, with biotoxins in particular, you can start to upregulate those histamine genes, which then start to trigger histamine in virtually every cell in your body. What's the net of this is antigen presentation and increased inflammation and immune activation. And of course, that becomes a vicious cycle because the immune activation triggers more stress on the brain, right? So great slide, simple diagram, but I think it's potent if you really get into this. And remember, when you look at that stress and that HPA axis, allostatic load plays a role in this, right? We're trying to get people back to resiliency. We're trying to get people back to durability, capacity, and being able to be resilient. And, allostasis, meaning your body's ability to deal with stress, versus allostatic load, when the HPA axis changes its ability due to, input of various types on a never ending, level on that HPA axis and creating pressure on it. And then there's just simply drugs that cause the microbiome. And this is interesting. There was a study that was a couple of years ago and actually just finished, doing research, and we're putting a database together on this. Ant wrote an ebook on it as well, which is, drug-induced microbiome disruption. And so antibiotics are obvious, corticosteroids are obvious, NSAIDs make sense, right? Oral contraceptives, PPIs and H2 blockers, because we block acid production completely, changes the pH of the gut. But then there's drugs like metformin and statins and antipsychotics and antidepressants and opioids that have a known disruption in the microbiome. And so we have to pay attention to that because that can be contributing to things. And, how many people that come into you that are CIRS cases that are already on some sort of antidepressant of some sort, or maybe they're overweight or type 2 diabetic and they're on metformin, or they're already on a PPI because of their GERD and how, thrashed and inflamed their GI tract and their stomach is. So something to just, obviously keep in mind. And then food sensitivities, there's a plethora of chronic conditions that it has been associated with. And I just wanted to kind of call out that there are a lot of issues just around food allergies and sensitivities, even if biotoxins or vector-borne illness like Lyme or related vectors are not present, you can get into these types of problems. So, I have plenty of people who their pain went away when we tested them for their foods, got them off of them and restored their gut balance, right? Sometimes just a very straightforward 1, 2, 3. Now we're talking about a much more complex group of people, right? We know it's an uphill battle with a lot of these folks to get them their quality of life back. And it's a long and arduous process. All the more reason to try to get that inflammation bucket, to be lower, right? Watch for the foods. So what's some targeted testing you can do? Obviously, zonulin is one. It's the only known real physiologic modulator of the intracellular tight junction. I think Claudin-2, you could argue, is also a piece of that puzzle because Claudin-2 getting upregulated by IL-6 will break down that cathode cage as well. Only known protein to reversibly regulate intestinal permeability. In general, it's tightly controlled. The innate defense mechanism, against bacterial colonization of the small intestine. That's zonulin's one of zonulin's roles. And then it's dysregulated by changes in composition of the microbiome. It's also by infection, right? So we know that, if your zonulin is really high, that it could be due to some sort of, dysbiosis, SIBO, or a bug, like an actual pathogen. And of course, this leads to issues around antigen trafficking control, which is lost. You lose mucosal tolerance, and then you have a permeability issue with the gut, otherwise known as leaky gut. I tend to like to refer to it as gut permeability changes, which is the traditional term in the literature. So, zonulin, for example, we all know the story, right? This isn't new. I mean, I started taking people off gluten in 1986. So it's not new, but we realize that there's two different ways that this occurs. There's the celiac person that has a true, very high reaction to gluten. And then there's the individual that's gluten sensitive, where they have a transient gapping of those tight junctions due to their gluten intake. And so it's just to keep in mind that with individuals that aren't necessarily celiac, that obviously gluten can be a big deal. And don't get fooled by somebody who comes in and they say, hey, I haven't eaten gluten in 4 years. And then you test them and it doesn't show a gluten intolerance. Of course it doesn't. You haven't challenged them in 4 years, right? You see it all the time. And of course, the issue here is that, when zonulin gets upregulated, you get monolayer, permeability problems. And, this is kind of the way it works with zonulin, right? Zonulin is helping, transcellular antigen sampling. You get encapsulation of it through lysosomes, encapsulation and then degradation via enzymes. And then that is the controlled antigen trafficking between A and B. Zonulin is working on when it gets upregulated, it starts to trigger the excessive antigen trafficking. And that excessive antigen trafficking and the zonulin receptors being upregulated breaks the tight junction gene expression, breaks that clathroid cage, leading to inflammatory cytokine inflammation and T cell activation and the loss of tolerance. So once again, I'm just trying to get that bucket of cytokines to go down. So why not tell them what foods to avoid other than just, oh, don't eat moldy foods, right? Don't eat histaminic foods. Well, let's get all the foods that have that IgG4 reaction and the C3BD reaction in place. And then meta-inflammatory conditions that are associated with increased zonulin levels. So this is just the evidence of this. This is all disease begins of leaky gut, the role of zonulin-mediated gut permeability in the pathogenesis of some chronic inflammatory diseases, published in 2020. So if you look at this, high zonulin's a consequence. You got to get to the cause. So it's CIRS, it's vectors, it's stress, it's diet related, it's exercise, right? Because people can exercise too much and trigger this kind of response. It could be nutrient deficiencies. There's many reasons at the causal level why zonulin gets upregulated. But the consequence of it is when it's upregulated, these are the conditions that are associated with upregulation of zonulin. So once again, high zonulin, leaky gut. Studies link zonulin with obesity, hypertension, impaired fasting glucose, and metabolic syndrome as well, which, by the way, is still the big things that it's out there in our marketplace of what we're trying to do to help people. 50% of people are diabetic or insulin resistant. Yes, some of those may be caused by CIRS, obviously by some of the recent publications that have been out on that you could be getting, this insulin dysregulation due to meta-inflammatory processes. So IRS1 and 2 are compromised, leading to more of that Warburg effect or GLUT1 translocational glucose, which of course leads to a lot of metabolic damage because you're only getting 2 molecules of ATP and a whole bunch of lactate and pyruvate in the cell, which, damages mitochondrial DNA, which leads to mitochondrial damage. So you can get direct mitochondrial damage, meaning that I'm upregulating NF-kappa B and creating an inflammatory process within the cell, say maybe due to liposomes or lipopolysaccharide, which of course is either hitting a receptor or translocating through the cell membrane and upregulating gene expression of inflammatory compounds. Or it can be indirect via this breakage and accurate and efficient glucose utilization, which is a feature of folks in this CIRS and biotoxin world, right? Many of them become insulin resistant and kind of induce what's called the Warburg effect, but kind of a non-cancer Warburg effect, but still the inefficiency of energy cycling and development. And of course, that's going to retard oxidative phosphorylation and reduce the way we make energy in our cells. So people get tired, they get fatigued, they get achy, and then they start to have poor mitochondria or ragged mitochondria, which induces more cell senescence and upregulating suicide, p53 suicide expression in genes, right? Histamine testing, real important. Obviously, histamine, a biogenic amine. It's in various degrees in foods. It's a neurotransmitter. People are getting very histamine intolerant, and this can be really basically an equilibrium problem between histamine and the capacity for histamine degradation. And part of that histamine degradation is DAO, but it's not everything. And I want to make note of that in this talk in just a moment. Obviously it causes dysregulation of the gut microflora. It triggers a lot of IgE response. You get impaired degradation of histamine due to diamine oxidase deficiency, which can either be genetic or can be acquired. And of course that can lead to histamine toxicity. And, high histamine foods, I made a list of them just so you have it. But once again, please think about getting a complete blood panel where you can really look at all the foods that could be driving histamine and not just high histamine foods, which could be more of the obvious things to avoid. But here's the thing that I think is interesting. So if you look at histidine to histamine, and how is histamine metabolized? Well, you have adenosylmethionine moving to adenylyl homocysteine, and then you get histamine and N-methylhistamine, which is under the influence of MAOB and aldehyde dehydrogenase, right? So the N-methylhistamine can be hitting that MAOB receptor. But the point being on this is that aldehyde dehydrogenase as the enzyme needed, whether it is DAO mediated or acetaldehyde directly affecting the imidazole acetaldehyde pathway of the histamine degradation, right? Which is, triggering that imidazole acetate. So whether you're on the right side or the left side, acetaldehyde dehydrogenase. So it's pretty important as an enzyme, right? Well, how many people with CIRS end up having candida? And no, mold isn't yeast. We got it. It's clear. They're two different animals. But when you have dysbiotic flora and an inflammatory process and a person not eating the right foods, they end up growing candida. Just tell them to stick their tongue out. Is it white? Is it coated? Is it geographic? Are they bloating? Are they gassy? Are they foggy headed? Many times there's a candida, situation. Why is that so important? Because candida expression down-regulates acetaldehyde dehydrogenase. So you get an upregulation of acetaldehyde, which of course is, toxic to the liver, but also changes neurotransmitter evolution in the brain, where you no longer make dopamine and serotonin, but you're making salsolinol and beta-carboline. So you're making phenolic compounds as your end neurotransmitter signal versus using the actual serotonin and dopamine, which could explain for some of the mood disorders that take place in these individuals. So remember, if a person has candida, know that candida, mold, they're separate, right? Yeast, mold, separate. But if they've got candida, they are not going to downregulate their histamine very easily because of the inhibition of acetaldehyde dehydrogenase. And so just really important. And so with histamine testing, obviously, a lot of different symptoms. I'm going to wait and go over the next slide for symptoms. But obviously, you could do a histamine-free diet. More importantly, get rid of all the allergic foods that would be triggering histamine. Test for DAO and histamine. Look at both. Plasma histamine ranges should be less than 1.8 nanograms per milliliter. All right. This was histamine and histamine intolerance in the American Journal of Clinical Nutrition way back in 2007. And obviously, you can look at urinary histamine testing if you wanted to. It varies by age. Just to note that, I put this chart in here for you. But here's I think the money slide, right? It's, histamine literally affects multiple systems in your body. So take a look at the central nervous system. So histamine altering neurotransmitter release, affecting the central nervous system, and leading to circadian rhythm issues and hyperarousal or sleep disturbances. You also see it contributes to body temperature issues, food intake, locomotion, learning, and memory. Just don't think it's, I'm neurally inflamed, it's microglial cells and it's inflammatory activity. You may need to get their histamine under control. And there's a lot of that we obviously are trying to control with what we're calling the mast cell, mastocytosis. But more importantly, recognize the fact that it's a histaminic gene upregulation globally in cells. So circadian rhythm, hyperarousal, that means trouble with sleeping, nausea, vomiting, headaches, vertigo, hypotonia or hypertension, and obviously anaphylaxis. And then there's also arrhythmias that can occur. You get pruritus, flushing, urticaria. Obviously, that's the one we think about when we hear the word histamine. But also endothelial permeability changes, and you get respiratory tract changes. Mucosal secretions go up with increased histamine. Just on a case this morning about that. Went to the allergist. He's, oh yeah, she thinks that all my drainage and my sinuses and my kind of tightness in my chest is all histamine. I'm like, yeah, well, probably right, because your heart rate's also high. He has a resting heart rate in the 80s. So that's that circadian rhythm arousal, arrhythmias, and increased heart rate that can occur due to histamine. And then, of course, histamine can affect estrogen. You upregulate estrogen, you alter smooth muscle contraction, which can affect the uterus, the gastrointestinal tract, which can lead to stomach aches and cramping, as well as dysmenorrhea and diarrhea. Gastric acid secretions can alter. They get upregulated with histamine. So we'll give them a PPI, right? Because now we're going to knock down their gastric acids. Well, they're still making histamine. So even though you corrected a consequence, you didn't get to the cause. And of course, bone marrow. So, you get, mast cell secretion, changes in regulation of hematopoiesis. So all of these things are happening just due to histamine. I think it's why it's important that you test for it. And I think it's important that you identify foods as well as environmental burden that contribute to this. Because I think this is one of the most significant aspects of what's going on with CIRS cases. And of course, that's why if you're doing something like a genetic genie test, they're looking at histamine receptors, right? To see if they're activated and how extensively they're activated. And are you turning them off with your therapy? And of course, DAO, a lot of different things can block DAO, but the more you drink, the more you block DAO. You drink a lot of tea, you have a lot of energy drinks, you drink a mate tea, all that can block DAO. And of course, there's a whole history of different types of DAO symptoms, which obviously would just be histaminic symptoms, right? Fatigue, migraines, muscle pain, vascular headaches, fibromyalgia, ADHD, just, part and parcel of this complex of metaflammation. And particularly with this weekend, discussing the impact of, CIRS type patients or mold and waterborne damage, buildings on individuals, as well as vector-borne, triggers in the immune system. And, what's some support for histamine symptoms? Like, there's a lot of things that you can give. Obviously, vitamin C and quercetin are important. I've got doses. I'm not going to go through these doses. You can read the doses. You can read the slides. But don't forget about magnesium. Don't forget about copper, because copper helps with that, with controlling that acetaldehyde dehydrogenase and acetyl-CoA pathways, and also helps with regulation of candida. Mangosteen, obviously, very high in flavonoids. Quercetin, probably the go-to in general. Stinging nettle leaf, tinospora, and then, of course, giving DAO. You can give DAO before a meal to help downregulate that histaminic response. Typically, it's actually extracted from kidney tissue, animal kidney tissue, not humans. And of course, can be very effective in histamine digesting units, is what it's measured in helping to break down that histamine when you're in a transitory state. So think about giving this really early on to get rid of that histaminergic drive. If you look at the histamine lab test, I've given you the ranges. Less than 2 nanograms per milliliter is optimal. 1 to 2 is kind of trending high, but probably okay, but watch it. And above 2 is high. And then, of course, there's secretory IgA, which is, productions, stimulated by bacteria and viruses. Patients have deficiencies in SIgA are susceptible to pathogens in the gut. Excuse me, get a little bit of a dry voice. Gonna get a drink. I used to do that on stage. Ulcerative colitis and Crohn have low SIgA. Just remember, when SIgA is high, it's either infection or inflammation. So you're at the high end. That means you're going to be moving to the low end at some point with SIgA. You're capturing where that person is at. What's the test look like? So if you notice here, IgE, IgG4, IgG, and C3BD, do you notice on the column on the far right, those are the C3BD immune complements that are going to dramatically upregulate the C3 pathway. So if you look over here on this individual, their IgG was crazy high. They had a very high IgG4, and they had an immune complement to gluten. So what you do is you go through, and what's nice about the test, it kind of breaks it down into 2 ways. You have a severe person, meaning they've got severe issues, or are they mild issues or more performance-based? I'm doing it out of interest, right? So if you look, it goes through a wide variety of foods. It helps you to target what foods you really need to be focused on. This test is covered by insurance, so I think that's incredibly important and highly accurate. So, the reproducibility on this is, well tested and validated. So once again, IgE coupled with IgG4 means you have pending driven IgE. Remember, IgG4 there to protect that IgE receptor and blocking the IgE antibody antigen response. And then, of course, C3BD dramatically upregulating that IgG, which you really start to wreak havoc on, like the metalloproteinases and the inflammatory cytokine cascades. And so this is how it looks, guys. You get a patient with less severe symptoms. They get rid of foods with high reactions to any of the 4 markers. So basically red, are eliminated from the diet. And then patients with severe symptoms are advised to remove all moderate and high reaction foods from their diet. And look, sometimes that list can be long and you kind of got to maybe pick and choose. Maybe if some of the yellows are just barely out of range and it's a food that they use, I'll have them rotate it. But basically, if you can try to get them to avoid the foods on the list on the severe restriction, you definitely dampen that inflammatory signal. I've seen it over and over again with this test, that it really helps people control their inflammation, and everything from I've got rheumatoid arthritis cases to psoriasis cases to MS cases where I've seen this really help them improve their symptoms, as well as in CIRS cases as well. So, really important to just note that it quickly assesses where the severity is, what of the 4 categories of reactivity are present, and then what you need to do about it. And then, of course, it also tests for environmental reactions. So you get a nice little panel on on environmental reactions as well, which can be very helpful. Fair amount of molds and fungus. And so really nice global test that you can get. And you can add histamine and DAO and secretory IgA and histamine to this. So you get a complete thought of where the breakdown is occurring in the individual and therefore start to think of treatment. So, test for it annually. Remember, 20% of the population is reported to have IgG food intolerance or sensitivity. Gut microbiome changes with age, but also with a variety of risk factors that I talked about earlier. And there is seasonal variation in the gut microbiome. That was first identified by Dr. Constantini in the World Health Organization, showing seasonal variation in sensitivity to mycotoxins, right? And of course, I think that was the real seed to a lot of what's happening today is Constantini's work at the WHO. And overall, we see gut microbiome can fluctuate based on stress or any other amount of factors. And so, eat more veggies, get those complex carbs in, get the resistant starch in so that you can make sure you're feeding those beneficial flora. And I've already kind of went through this with you, understanding all the different things that can affect the gut microbiome. This is just a quick review. So please remember to check these lists. And I want to thank you for my time today. I hope you got something out of this discussion. I hope you all have a great day and a wonderful conference. See you later.